Gravity, the most important phenomenon in our lives, a power that keeps the universe together, the reason why we're not floating in space, and a force causing orbital motions of planets. Today, we are here to talk about incredible aspects of gravity. We've all heard the story of Newton and that falling apple, and we regard it as the beginning of his discoveries about gravity. In fact, when Newton observed that famous apple falling down, he discovered that the force pulling the apple downward is the same one acting on the moon that makes it rotate around Earth. Newton realized that every other object in the universe must follow the same rule. So he finally came to his universal law of gravitation, which states that every two particles located at a distance from each other have a mutual attraction. Newton considered this attraction to be a force whose magnitude is obtained like this, where g is a universal constant called the constant of gravitation. As an example, let's find out the amount of gravity exerted to Moon by us. We've got the masses and the average distance between them. If we plug in these values, we'll come to this gigantic number. It is also good to know that Moon's gravity causes the tides of the oceans. Another great thing about gravity is its ability to keep satellites in orbit. Rocket launchers must throw them with a proper velocity at which Earth's gravity would be able to provide the required centripetal force. In this case, as long as gravitation is the only force applied, Newton's second law gives. According to this relation, the closer a satellite gets, the faster it should move. Anyway, if every two objects are attracted to each other, why don't we feel anything? It is obviously because of capital G. This coefficient is very small and it leads to a negligible force. Since we're not dealing with supermassive objects in normal life, we just need to worry about Earth's gravity. Therefore, we use a simplified equation that corresponds to Newton's second law. F equals mg, or better known as weight equals mg, where the lowercase g is defined as the gravitational acceleration and it can be determined like this. Be careful that our planet is not a perfect sphere, and the magnitude of g depends on our location. However, its average value is estimated to be 9.8 meters per second squared. All particles on Earth, regardless of their shape and mass, experience a downward 9.8 meters per second squared acceleration. Now you might be wondering why heavier objects fall much faster than lighter ones. Well, this is not always the case. At the absence of Earth resistance, both feather and ball fall at the same rate, which means they hit the ground at the same time. It may seem a little weird, but from kinematics we remember that a thrown object with no initial velocity hits the ground at the speed of. Newton's theory was not successful to explain the real nature of gravity. This phenomenon is most accurately described by Einstein's theory of general relativity, which states that gravity is a geometric property of space-time and not a force. However, most engineering fields are based on the classical theory. For more amazing information about gravity, don't forget to check our next videos. Thanks for watching us.